function, or in short MGF. The moment generating function of a random variable capital X is nothing but the mathematical expectation of e raised to tx, which is also represented as m suffix x, a function on variable t, which is known as the rth moment generating function. Moment generating function is just the name given to the quantity expectation of e raised to tx, where capital X is the random variable, and moment generating function is given the notation m suffix x, a function on t, which means that m stands for moment generating function on random variable capital X, and this will be a function on variable t. How comes such a name, moment generating function, for this particular function? We have expectation of e raised to tx can also be expanded as expectation of 1 plus tx plus t square x square upon 2 factorial plus t cube x cube upon 3 factorial plus etc. Because we have e raised to x has the expansion 1 plus x square by 2 factorial plus x cube by 3 factorial plus etc. Because e raised to x can also be written as summation over n x raised to n upon n factorial. We just substituted x equals tx in this expansion and we obtained e raised to tx can be written in this format. Now we apply the expectation function e to every term. We have expectation of 1 is 1 itself. Expectation of tx can be written as t times expectation of x, because expectation function is linear function. So t can be taken outside and expectation of x is obtained. Expectation of x can also be written as mu1 dash, which is the first raw moment about 0. When expectation is applied to this term, t square by 2 factorial is taken outside and expectation of x square is obtained. Expectation of x square is mu2 dash, which is the second raw moment about 0. The general rth term after we have applied the expectation will be of the form t raised to r upon r factorial taken outside, and we have expectation applied on the variable x raised to r. When we have expectation of x raised to r, which can be replaced by mu r dash, which is the rth raw moment about 0. Thus we have moment generating function, which is expectation of e raised to tx, has this format. Notice that coefficient of t raised to r upon r factorial in this expansion is giving us rth raw moment of the variable capital X. That is, whenever we look into the coefficient of any general t raised to r upon r factorial, we are getting rth raw moment. Therefore, this moment generating function does give us information about moments. It does generate moment, and that's why it's known as moment generating function. Another important fact is that when we consider derivative of moment generating function mx of t at t equals 0, when you consider the first order derivative d by dt, you are having the answer mu1 dash plus t times mu2 dash plus etc. t raised to r minus 1 upon r minus 1 factorial into mu r dash plus etc. This is obtained because you are taking derivative of this expansion with respect to t. So derivative of 1 will be 0. Derivative of this term with respect to t will be mu1 dash. Derivative of this term with respect to t will be 2 times t upon 2 factorial. 2 gets cancelled from numerator and denominator, and we have the answer after differentiation and cancellation as t mu2 dash. So in general, we have the differentiation of this rth term with respect to t will give us t raised to r minus 1 upon r minus 1 factorial into mu r dash as the answer after differentiation. To this expression, now we have to give t equals 0. When you give t equals 0, all these terms will vanish and you have mu1 dash. First order differentiation of moment generating function with respect to variable t, and after that giving t equals 0 will generate the first raw moment about 0. If you consider the second order differentiation of moment generating function with respect to variable t, and after that you give t equals 0, you will get mu2 dash. If you give third order differentiation of moment generating function and you give t equals 0, you will get the third raw moment about 0. In general, we have the differentiation of order r taken with respect to t over the moment generating function. After that, giving t equals 0 will definitely generate mu r dash, which is the rth raw moment of the random variable x about 0.